Gentlemen, welcome back to Innovators Corner. I'd like to introduce you to Mr. Calvin Cheung, who will be he's from TARDEC, and he'll be talking about the Autonomous Ground Vehicle Reference Architecture Overview. Thank you.
All right, good afternoon, everyone. My name is Calvin Cheung from TARDEC, and I'm here to tell you about the Autonomous Ground Vehicle Reference Architecture, otherwise known as AGVRA. All right, so first off, I just want to zoom back out and look at the bigger picture. So the Robotic and Autonomous Systems, or RAS strategy, is the strategy that the Army is using to look at how they want to implement robotics and autonomous systems in the near and far term. It talks about how we want to do a lot of capabilities, such as increasing situational awareness and increasing force protection. And in order to do these things, we need greater capabilities in a lot of software-intensive systems, such as autonomy, artificial intelligence, and command control. The bottom line here is that implementing the RAS strategy is going to require a lot of development in some software-intensive systems for us to be able to leverage rapidly advancing technologies. So what are the challenges in this? So overall, when trying to acquire and develop software-intensive systems, there have been a lot of challenges in government acquisitions. There's often cost and schedule overruns because planning software is difficult. There's high maintenance costs and limited reuse across programs. This is because a lot of development ends up being closed shop efforts with little reusability between different programs. And overall, the rate in which technology advances in industry is slower than the rate in which it was brought over to the military domain. So in order to help solve some of these problems, the RAS strategy talks about using open standards and architectures, or OSA. So through using open standards and architectures, we can get some cost savings by having commonality between software components and platforms. It allows us to do faster upgrades and support innovation with accelerated capability development. And it gives for greater modularity to have better integration between different mission sets. And the use of open systems and architectures is nothing new. It's been used in industry. Things such as web protocols, mobile operating systems, even shipping containers have leveraged these to great effect to have a lot of savings and commonality between different companies. So despite the usefulness, there are challenges in using OSAs. So in order to use the OSAs, you need to have careful planning to make sure that all the different standards and architectures that you want to leverage work together. Even within the Army itself, there are dozens of different RAS-relevant standards. However, there's no good documentation explaining how they work together. There are things such as IOP, Victory, FACE, etc. A lot of different standards and architectures, but there's no high-level guidance that tells us how to bring them together in a robotic system. So overall, the bottom line is that guidance is needed to effectively implement this open standards and architecture strategy. And that's where AGVRA comes in. So the high-level purpose of AGVRA is to provide a set of guidelines to enable the robotics community to fulfill the RAS strategy, allowing us to use, have modularity and common standards to have affordable development and advancement of technology. Overall, it will broadly increase our understanding of OSA and increase innovation by reducing the integration burden. The objectives are basically to leverage the best software behaviors, to enable code reuse and modularity, to fuse development and testing, and to be able to let vendors leverage their expertise in niche areas as opposed to having to start from the ground up. So the bottom line here is that the AGVRA provides technical guidance for the implementation of the RAS strategy. This lays out the development plan. Right now, we just finished out phase 0, which is the concept description. In this phase, we looked at the architectural concepts overall and helped give some guidance about how they should be applied to different development programs. We did a survey of current and existing standards and open architectures to let people know what's there, what's ready for use, what needs further development. And we also looked at some current and near future implementation architectures to talk about how they are currently being used. As we go on, we're going to further develop this by having architecture descriptions and actually reference implementations. And this will have actual technical implementations and reference plans so that we can have something that everyone can look to develop robotics to have commonality across systems. Something important to note here is that as we further on develop this idea, we are increasing industry leadership in this as well, because this is meant to be a joint government and industry effort. this isn't solely government. We need to work together to make sure that we're all on the same page as we move on to develop the capability. And this goes through how the concept description came about. I guess the important thing to note here is the participants. So in developing this, there are many groups across TARDEC. We brought in many open architecture SME subject matter experts, such as the chief architect of Victory, one of the lead developers of UCS. And in addition, just general subject matter experts in the robotic autonomous system domain. We've been working very closely with MIT Lincoln Labs throughout phase 0, and we'll continue this relationship as we go on in the development of AGVRA overall. This slide is just to show that in order to do this, we had to take a top-down and bottom-up approach. Top-down in that we had to look at kind of higher-level architectural concepts to be able to properly explain and understand them to the different programs that need to utilize these things. And bottom-up in that we also looked at current existing architecture standards and programs to see how the Army is currently utilizing them and to make sure everything fit together in a way that is actually well understood. This slide goes through the different sections of the concept description. Some things I'm going to focus on are the stakeholders, the architectural viewpoints and quality attributes, and the analysis of relevant architecture efforts. All right, so for stakeholders, in order to properly determine the stakeholders, we examined the RAS operational concerns, the RAS technical objectives, and Better Buying Power 3.0. And through looking at that and running through the ISO 4210 architecture description, we determined that the relevant stakeholders are there listed on the screen. There's the Army user community, our acquisition community, R&D community, test and evaluation community, contractors and vendors, and the standards and technology development community. And using those stakeholders and the documentation from the RAS and Better Buying Power, we help determine some high-level concerns that those different stakeholders care about. So basically, the different stakeholders will have different problems or areas of things that is in their domain that they care about when developing RAS. So what somebody needs who is an Army user is going to be different than what a Army R&D developer needs. So by mapping the concerns out to the different stakeholders, we're able to properly address what they actually need to move forward. And using those stakeholders and concerns, we're able to create different architectural viewpoints. So these architectural viewpoints is what those stakeholders should use to solve the problems relevant to their domain. For instance, someone in the PEO office will have a greater concern over what the general open business model architecture is versus someone in the standards community, which will not care about such a high level of what things are, but will need to know more about the, let's say, target systems architecture. So with those stakeholders, concerns, and architectures, we're able to create a list of quality attributes to help those stakeholders rate what architectures actually fit their needs. So the quality attributes can be used to inform what architectures to use based on the qualities important to the different stakeholders. For instance, this lists the business participant architecture. So if the stakeholder cares about government collaboration, then the architectures that they need would have to have good ownership boundaries, governability, manageability, and security. So where all that comes together is the architecture survey that we provided. So in doing the architecture survey, what we did was we looked at existing standards and architectures relevant to AGVRA, did a characterization and comparison of everything, and looked at the different architectural viewpoints to figure out what the different quality attributes existed within the different architectures. This benefits everyone greatly because it allows us to leverage work done prior in defining the standards. It can leverage lessons learned from these previous efforts, identifies the strengths and weaknesses of these different standards and architectures depending on what your focus area is, identifies areas of commonality, and it provides an initial assessment of how this relates to the AGVRA and how it can be brought together in a coherent system. These next two slides show a list of some of the architectures in the survey shown. As you can see here, it goes through the effort categories, the effort objectives, domains. The actual document itself has a lot more information. I think it combines to say 300 pages, so it's a pretty beefy document. But note that if you look at the effort category, we didn't just look at the RAS architectures. There's enabling technologies that we had to keep track of because those are important to the development as well. So we had to make sure that everything that we looked at that had open standards and architectures was properly accounted for. And with the survey and with the architectural concepts, that brings together everything for the initial concept definition. Future works that we're going to further explore and refine the requirements of the different architectural realms. We're going to investigate the feasibility of having AGVRA technical architectures, which will combine the existing architectures to have the reference to show how to use everything in the development of the system. We're going to develop the requirements and recommend an approach for data information architecture. And we're looking to develop and recommend a strategy for model-based system engineering to help stakeholders have a method to generate program requirements, evaluate coverage of existing artifacts, and automate acceptance testing. So that's AGVRA in a nutshell. If you have any questions, I think you can ask them now, or if not, I'm in the booth back there in the AGVRA area. Thank you for your time.
George Poulos, Army Innovation Group. Do you have any plans right now to socialize this, like with the other services or SOCOM or some of the other groups dealing with autonomy, in order to make this broader than just TARDEC and Army baseline?
Yes, we do. Let me see if I have that on the timeline. It's supposed to be released in April for government review. Right now we're going through internal review, and then after we do the internal review, we're going to socialize it to the greater government group and then to industry as well. So there is definitely plans to socialize this to make sure that, because we don't want this to be a TARDEC thing. We want this to be a government/industrial thing, because for this to be successful, everyone has to be on the same page with the use of these standards and architectures. So actually, if you want to come stop by my booth later, let me get your contact information, and we'll be sure that your group is involved. Okay, if there are no other questions or comments, you can find me over there. Thank you very much, everyone.